Alright, in this video, we're gonna do number 2 and 3, and the numbering was off on that. It's the number 2 that's on the back of the page. So we're gonna do the back of the practice for Unit 6, Lesson 2, Part 1 practice. Alright, so it says, Mrs. Ressler really likes to read. The equation B of T equals 20 times 5 to the X describes how many books Mrs. Ressler has in her collection after T years. So based on the equation, how many books does her collection start with? So this is making sure you understand exponential. Remember, the first number you see is called your starting value. So 20 here would be the number of books that Mrs. Ressler starts with. Now, how does her collection grow each year? Well, that's the growth rate, the number in the parentheses, which is a 5. That means that her collection multiplies by 5 every year. Exponential functions are multiplication. Linear are the add and subtract. Based on this model, how many books will she have after 4 years? Well, we're going to find the number of books after 4 years. We're inputting the number 4 to be 20 times 5 to the 4th power. This is where you need Desmos. So we'll take our 20 times 5 to the 4th. And there's 12,500 books in her collection just in 5 years. All right, finally, using the table on Desmos, we're going to estimate, and I'll show you how to do that. We want to know how many years it will take her to acquire 1 million books. So here's how we're going to do this. To use the table on Desmos, and you can use your calculator for this too. If you need help with that, let me know. We're going to type the equation in. We're going to use y's and x's on Desmos. So y equals 20 times 5 to the x power. That's the picture of the graph. Now we're going to make a table here. Here's our table. Now we want to know, when does the value in the y's get to be 1 million? So right now we can't see, so we need to add some numbers to our table. 3 isn't quite there yet, 4 is at 12,000, 62,000, 312,000. Ooh, 7, now that's scientific notation. 1.56 to the times 10 to the 6. Let's talk about that. So I'll do 1.5 times 10 to the 6. Now, scientific notation you did in physical science class. What that means is you need to move the decimal place after the 1 over 6 to the right. Since the 6 is positive here, that means I go 1, 2, 3, 4, 5, 6. And that's where my new decimal point would be. And I fill all of these in with zeros. Now, if I had that number, that'd be a 0.0 after. I won't put that there. That's going to be, let's see, I'll rewrite it without the marks. That number here is 1,500,000. So it's going to take between 6 and 7 years for her to get 1 million books. So let's look at the table again. At 6 years, she's at 312,000. At 7 years, she's at 1.5 million. So somewhere in between 6 and 7 years is where she hits that 1 million mark. We'll do more of those with the table. Now, number 3. 3 brain-hungry zombies have made their way to the city of Delaware and are turning humans into zombies. The table shows the number of infected people. So I want you to first write a model. Now, when we write a model, we need to figure out our starting value. That's always at day 0. So at day 0, there are 3 zombies. So that's the number we start with. Now, in parentheses is the number that the growth rate is. Now, going 3 to 6, to multiply there, you would go times 2. 6 to 12 times 2. 12 to 24 times 2, over and over. It means we're doubling. We're multiplying by 2 here to the x. That would be your model. Now, if you're not sure, this is where your calculator or Desmos can help you. Type y equals 3 times 2 to the x in, and then look at the table. You have the same numbers, 3, 6, 12. If I put 3 in here, 24. That matches the table that you have, so you know you wrote the right equation. Using this equation, how many zombies will there be after 25 days? Well, I'm just going to put 25 in for x. 3 times 2 to the 25th, and I'm going to use Desmos for my table. Since I already have a table, I'm just going to put 25 in for my x value. And I see that I have a weird decimal. Let's see if we can avoid that. If I type in 3 times 2 to the 25. Okay, there, it doesn't give me scientific notation there, so I'm going to use that number. 100,663,296. So I'm going to use that number because it doesn't have the scientific notation. So let's write that down. So after 25 days, there will be 100,663,296 zombies. Now, still using our table, between what 2 days will you reach 10,000 zombies? So going back to what we did, we already have the table here. Let's keep going from 3. Let's go to 4, we're at 48. 5, 6, we're getting bigger. We want 10,000 zombies. So I'm going to keep going. We're on 768 there. 1,500. 11, we're at 6,000. And 12 is 12,000. So somewhere in between 6,000 and 12,000 is 10,000. So be between 11 and 12 days. All right, if you have questions on the other 2 problems on this practice, check the key that's posted on Canvas or ask your teacher for some help.